these are quite brief. I only got my systems last week for testing. So what we're looking at is a system the oldest possible that could run Windows 11, so the Precision 3630 from 2018. I managed to rescue that out of our training room when it was retired a good number of years ago. And then a 2021 desktop, again, managed to steal and keep it to one side for testing, and the latest Dell ProMax Tower. So they're kind of our high-end spec, but the reason I get these is to kind of work out what is the best value for money and come up with a series of recommended specifications. Now, if we look at a part rebuild, so this is how long it takes to control Q rebuild this model. This is something that takes around half the time on the later system, and it's still around the sort of 30-40% faster than the 2021 system. I always need a new model for this. It's always getting too quick. Long-serving SolidWorks users might recognize this is actually someone from the forums who originally put forward this model, and then it got included in the SolidWorks benchmark. But this is a manually timed result. One thing to note here is that the results you see under performance evaluation, they were around sort of 20-25% quicker than the actual return of control of the mouse. So always, I do it manually. I take an average of 3, and I make sure it's kind of consistent before I'm confident to show these results. It's pretty similar for how long it takes to open assembly. As Alan said, it's not the be-all and end-all, but it's quite representative of, an intensive task that's going to use a bit of CPU, a bit of disk transfer, and also a little bit of graphics, rebuilding that. And again, we're getting sort of less than half the time on the latest system. And this is using the new optimized resolve mode. Didn't really talk about it much when it was originally released, because until one of the service packs in 2024, it didn't support SolidWorks PDM. So given most of our largest customers use SolidWorks PDM for best performance, if you're working sharing a model across multiple users, you want to be using PDM because it caches locally, but it also gives you that ability to work collaboratively. So now it's supported. It actually made about 30% difference, somewhere between 25 and 30%. The largest difference being on the newest system. It's quite reassuring, seeing that improvement. So it was taking about a minute and a half in fully resolved mode. This new optimized resolve mode, which blends lightweight and resolved, it took less than 50 seconds on the latest system. These are also optimum for SolidWorks simulation. And we do test other CPUs. I did these the other way around, so apologies, just the screen grabs the other way around. But taking under 3 minutes on the latest system. This is just a SolidWorks static simulation. So again, it's going to vary based on the solver, the size of the problem, etc. But this one it's quite consistent, showing performance improvements with the latest CPUs. And what we're seeing here is kind of beyond what you might expect on paper, because when you look at the CPU speed, it's only actually increased maybe 10-15% the maximum speed, but we're seeing massive improvements. Each generation can do more work per gigahertz, so we're seeing a bigger improvement than you might expect. And on flow simulation, this actually showed the biggest difference, and probably one of the tasks where actually I saw a significant difference versus last year's model. So the old Precision 3680, it's still what we're offering at the moment. So these have only just been released, just been certified for SolidWorks, the new Dell ProMax Tower, and we're trying to get in our range together. So in May we'll start offering these, but it did show a huge difference for the flow simulation. That's one of the most multi-threaded tasks in the SolidWorks portfolio. So these got 24 cores versus 6 on the old Precision 3630. So I'm expecting that kind of difference. And it is one of the few places where we actually saw a benefit for the systems with more cores, particularly the AMD Threadripper based systems with 32 or 64 cores. The key thing is, I'd say, always come to us for advice, because bizarrely, when I went and tested a 96 core system, it was slower. So there's always some wrinkle in there. There's something that might catch you out. We didn't find such performance improvements with the Intel Xeon based systems, but we're always testing. We're finding those were 30-40% slower for CAD, so we weren't going to recommend them unless they were particularly fast for something like simulation. We didn't really see that. The AMD Threadripper based systems, so the Precision 7875, it may be 2-3 times more expensive, and we were seeing it maybe a little bit faster for flow simulation. And then don't forget, we also now offer a wider range, so the Dassault Simulia range, things like Abacus, maybe a familiar name for high-end simulation. We saw those CPUs with a massive memory bandwidth and memory support were beneficial for that, but not products within the SOLIDWORKS range particularly. We were seeing mainly just for the flow simulation in the SOLIDWORKS portfolio, and then those high-end simulation products that we offer from the wider kind of Dassault product range. So just to bring it all back together, so it looks like, based on the poll results at least, it's probably time to upgrade for a good number of people, and hopefully this has helped you kind of figure out, well, what do I need? And we're here to help. So make sure you've got an upgrade plan. Ideally, it's so it's rolling. You continue to upgrade SolidWorks, checking things like the system requirements. Does my system still support SolidWorks? Do we have servers for PDM or licensing or electrical? Are they still supported for the latest release? At a certain point, Microsoft stopped support, and therefore so does SolidWorks. And if you're on Windows 10, now is the time to start planning. It's only got about 6 months to run until its end of support. So get that in place. Make sure you're getting those plans and budgets available. I would always say reach out to your account manager or our support team. They're happy to help with advice. I said there's no commitment. It's not just going to say, well, buy something from us. We're here to help. We don't want to have everyone calling up in October when the support ends and you're in a bit of a sticky situation. So something you can do regularly. You can review your SolidWorks PCs, what the specs are they supported, are they going to work with the latest release, are they optimal? Same for servers. We can give you that kind of advice. And you can also help you work out, are you have a look at a data set perhaps, are you using the best practices, are there things we can help out with on that side? And we want you to avoid that situation where you bought a system and it didn't work out. And this is why I started doing recommended specifications. We had customers asking, if you go on the SolidWorks site, it'll tell you what the minimum requirements are. We want to tell you what's going to perform well for your workflow. It's a bit more complex now because there's more products. We only really did parts, assemblies and drawings when I started, maybe a little bit of simulation. Now there's a wide range of products, visualization, simulation, flow simulation, etc. It's quite easy, particularly on the desktop side, to spend many multiples of the cost of our recommendations and actually get worse performance. So that, going for something that's 30-40% worse, and it's a bit of an awkward situation. It's difficult for us to have that conversation after you've already spent the money. So please come to us for advice. We're happy to help and give you that advice on what we recommend, whether you're going to go through us. So we have some good deals on Dell systems and Dell Pro Max workstations and Precision laptops. And even if you're not going to go for us, we'd rather you get the right advice. We don't want you to just go away and choose something that isn't suitable for SolidWorks.